Good morning, Internet friends, and welcome to Dev Update number 4. I've been making a lot of development progress over the last couple months, but I haven't put out any videos, and that's been because all of the progress has been kind of interlocking and hard to separate into clean, succinct videos. And so today, I think what I want to do is just give you a quick overview of the various things I've been working on and not go too deep into any of them because I'll do separate videos about each, actual milestone deliverable once they're done in a couple weeks. Okay, so the first 3 dev updates were about getting the local ElectionGuard software to work the way I wanted it to. And now for the last couple months, I've been moving on to milestone 2, which is all about the Cardano blockchain and IPFS file syncing stuff. So the elections are still working the same way they were, but I'm gradually transitioning them from working locally on one machine to working in a decentralized way over the internet. And because there are 2 separate parts of that, there's the posting the hashes of each file on the blockchain, and then there's the syncing all the actual files by IPFS. I've kind of split into 2 development tracks, and I've been working on both of them simultaneously or alternating back and forth. So on the posting things to the blockchain track, I have a first simple version of the smart contract. It's written in Aiken, and what it does is it's just a pub sub channel. So you open a channel, which mints a channel NFT, and then every time you update the state of that channel NFT, you post some more IPFS content identifiers. So it's like at each stage, there's a list of new hashes, and then you get the full history of the channel by running a little Kupo indexer. One set of Python code does the publishing and generates the transactions, and then they're validated in Aiken, and then there's a separate little Python code base that subscribes to a smart contract using Kupo. So you just set the subscriber running and you give it the policy ID of the channel NFT, and then it'll continuously update the list of content identifiers based on whatever people have published. So that works. It took a while to learn some of the details of how to do Aiken smart contracts and PyCardano and make them work nicely together, but I think I have it working pretty well now. If you want to see how this part of it works, you can go to my GitHub repo and then go to milestone 2 and then pubsub 2 Aiken PyCardano Kupo. Very descriptive. And the things you can do are you can generate a new preview testnet key pair, and it'll do that automatically for you. You just run the Python code, and then you can run the tests using PyTest, and those will use your generated wallet to post a series of test channels on the testnet. And you can also take that wallet address and paste it into Cardano scan, and you can see the transactions gradually accumulating, and you can look at the minting and burning of the various channel NFTs if you want to. So that's the first of the 2 development tracks, which is about posting IPFS content identifiers on the blockchain. Then the other development track is basically everything else. If you remember way back to, I think, my first dev update video, my architecture for all of the milestone 1 elections was that there's a top-level Python script, and then it controls a bunch of individual ElectionGuard Docker containers, and each one acts as one node or entity in the election. And the way they share files is that they're all just bind-mounted the same public records folder. And so they put their public records into the folder, and then everyone else can just immediately read them. So what I've been doing lately is transitioning that gradually to be a more realistic, decentralized internet syncing thing. And so the latest code base I have for that, if you go in the GitHub repo, is under milestone 2, and then it's called mockchain local IPFS parallel. And the way this works is each node, instead of just being 1 Docker container anymore, is a triplet of 3 Docker containers. So the first one is ElectionGuard Python, which is the same reference implementation container as before. The third one is an IPFS instance. And then the second one is something you haven't seen yet, which I'm calling EG Sync for ElectionGuard Sync. The EGSync container is a little web server that has a very simple API that's basically just get public record and post public record. And so it looks to the ElectionGuard Python code pretty similar to the old shared folder. So the Python code can just be like, load the ballot with this ballot ID. And it calls the API for that rather than looking in the file system, and it gets back the JSON. But on the back end, the EGSync container is maintaining its own election state based on things it sees on the blockchain and pulling the files from IPFS. So now rather than having one shared folder that's bind mounted to all the nodes, each node is maintaining its own state and they're actually just talking over IPFS. The other new thing going on here is that there's a little bit of Docker networking fanciness. So within each triplet that represents a node in the election, the ElectionGuard Python container is on its own little subnet that can only talk to the EGSync container. And then there's another subnet that lets the EGSync container also talk to the IPFS container. But the ElectionGuard container can't talk to the IPFS container or to any of the other nodes. It's isolated. Then the only thing that networks all of the triplets together is the IPFS containers are on their own IPFS network. So that pretty effectively mimics all the communication going over IPFS. Now, if you're sharp, you might notice that they also need to talk over the blockchain, right? And I just said that I don't have a complete version of that working yet. All I have is the first simple version that posts lists of content identifiers. And so what I've been doing is I made a little thing called the mock chain, which is basically a folder that's bind mounted the way the old shared public records folder was. But instead of having the actual public records, it just has a bunch of little JSON files. And each JSON file contains what I want to post on the blockchain in the next iteration of the smart contract. And that lets me experiment with more complicated protocols faster than I would be able to if I have to actually implement the smart contract and test everything. So I have a more complicated version of the contract working in this mocked up JSON files setup. And the way it works is it's a multi-threaded pub sub channel. So there's the main administrator thread that has a main channel NFT. And then the administrator can also mint other channels. So it can mint like a Guardian 1, Guardian 2, Guardian 3 channels, device 1, device 2, verifier 1, and so on. And then each of those other nodes will be authorized to post things to their specific channel. And so that way the election can run lots of things in parallel without their UTXOs conflicting and without any particular complicated coordination needed to make the batching everything into a single thread work smoothly. So I have the mock-up version of that actually completely working, and this code base runs all of the old election tests from the first milestone, except I removed the attack ones because to get them working in this, I would have to rethink how the attacks are structured a little bit because they were based on editing the file after it was posted. And in this setup, it's more like a real blockchain in that you can't edit it after it's posted. So I don't think that having the attacks work is actually an important part of this. So for now, I just commented them all out. But other than the attacks, all of the old tests still run, which proves that this multi-threaded pub sub channel mock chain idea should work if I can implement the actual smart contract that works roughly this way in Aiken. So that's the plan for finishing milestone 2 up in the next week or two, is just to merge these two development tracks so that we have one code base that runs a multi-threaded pub sub channel and shares artifacts over IPFS and their hashes on the preview testnet. And then looking ahead a bit, the main thing to do in milestone 3 will be to decentralize the last part of it, which is this top-level Python script controlling all of the nodes. So we want to go from that to having a separate interface per node and being able to actually run them on different computers and have people manually enter things or have it scripted, but have each one being controlled independently and making its own decisions in a decentralized way, rather than controlled by a top-level script. And then, of course, putting some effort into making a nice demo and giving a talk about it. This has been Dev Update number 4. Join me next time, and I'll hopefully have a complete working version of this combined codebase, and I'll give you a little tour of it and explain how the first version of the complete smart contract works.